Hello, this video is section 8.1 in the Larson book, testing the difference between independent means, population standard deviation known. All right, now instead of testing the mean of a population against a numerical value, in other words, like mu equal 50 or mu greater than 100, we're going to compare two groups against each other, a mu1 and a mu2. All right, so let's talk about this first definition here, independent. Two samples are independent when the sample from one population is not related to the sample from the second population. And two samples are dependent when each member of one sample corresponds to the member of the other sample, also known as paired samples or matched samples. Okay. And so, like this example of independent, you have systolic blood pressures of 30 females, adult females, and adult males. There'd be no kind of correlation there. This one, dependent, midterm scores of 14 chemistry students and final exam scores of 14 chemistry students. Okay, generally dependent samples are a lot of times where they're the same group of subjects and there's some sort of change or something. Another example I've seen, for example, let's say if you took, I don't know, the resting heart rate of 20 people and then took the same 20 people after each one of them maybe had been on a treadmill for 15 or 20 minutes and measured their heart rate again. That would also be dependent, because anytime it's the same group of people, it's dependent. Independent needs to be two completely separate groups of people. All right. Now the conditions that we need, both population standard deviations are known. So that's why you see we got subscripts here, sigma 1 and sigma 2. Samples are random, samples are independent, populations are normally distributed, or both of them are greater than or equal to 30. So that's probably what we'll mostly have, is just have them greater than equal to 30, but if not, they would have to be from a normal population. Now you can, in this, I'm not going to do this, but you can actually compare these by specific amounts. Like, for example, you could say is mu1 minus mu2 is less than 10 or something. You can compare it to a number, but we're just going to compare them literally against each other. So you see the symbols are the same, but we don't have numbers this time. So this would be mu1 equals mu2, and then mu1 not equal to mu2 for that two-tailed test. Here's mu1 less than or equal to mu2, mu1 greater than mu2, and that's a right-tailed. And then mu1 greater than or equal to mu2, and mu1 less than mu2. That's your left-tailed test. Okay. But technically you could compare them against a numerical value. Like, well, we may think one of them is bigger than the other one by 10 or something like that. All right, so yeah, now I mentioned up here to avoid confusion regarding left-tailed and right-tailed tests, when we read a problem, now it may be labeled for us. Sometimes it just gives you the data labeled, but if it's a word-type problem, we'll automatically treat the first group as mu1 and the second group as mu2. Because of the confusion you could run into is, for example, saying that mu1 is less than mu2 is the same thing as saying that mu2 is greater than mu1. So it could get confusing. It would kind of mean the same thing, but it would make it confusing to identify for consistency purposes what we should do. So we'll do it that way. All right, this is the test statistic. You're not going to have to worry about using that. And I mentioned here that if if they're both 30 or more, technically you could use the sample standard deviations. Pretty sure on the exam I have them, they'll be both populations, but we'll see what comes up in as far as any homework problems. But this kind of goes into that idea that if they're larger size, it's okay to use S instead of sigma. Okay, here's example 1. From a certain hospital group in the U.S., we collect a sample of 80 doctors and find their mean IQ to be 118 and a population standard deviation of 22. Sample of 70 nurses have a mean IQ of 128 and a population standard deviation of 25. We claim that the mean IQ for the doctors is less than the nurses. Test this hypothesis using a level significance of 0.05. All right, so as I said earlier, whatever group you see first in the problem, we want to treat that as group 1. So the doctors were given first, so they're group 1. So I wrote all their information right over here. The nurses were second, they were group 2. So if we're saying we claim that the mean IQ for doctors is less than the nurses, that would mean our claim is that mu1 is less than mu2. That's our claim, and then therefore it would pair up with a HO of mu1 greater than or equal to mu2. So let's take a look at this using the p-value method. And in the calculator, that's going to be stat, test, third one down, as you can see in the screen right there. 2 sample z-test. These are definitely going to be z-tests. So you have to be careful how you enter this. It's weird the way they have it set up, I think, because you see they have the standard deviations for 1 and 2, but then they do mean and n, sample mean and n for 1. So it goes 1, 2, 1, 1, 2, 2. So just be careful and you'll be fine. I find that to be odd. It seemed like they could have done 1, 1, 1 and then 2, 2, 2. But I don't know. I did not program this calculator. So the doctor's standard deviation is 22. Nurses is 25. Sample mean for the doctors is 118. The sample size for the doctors is 80. 80 doctors. And the sample mean for the nurses, 128. And the sample size for the nurses is 70. And then you got to pick the correct one of these, and it's a less than, so we pick the middle one. Calculate. And let's see, everything in this screen here on the right matches what I just did. Sure does. And there's the p-value. 0.00488, whatever. Now, okay. All right, looks like I went ahead and stated the conclusion without, which I'll do the Excel, but yeah, but okay, so 0.0049 is definitely less than your alpha of 0.05, and that means we reject the HO, and we support the claim that the doctors have a lower average IQ than the nurses. We agree with that. So let's show how to input this in Excel. And right down here, we're not doing two means. So two means Z distribution. And of course you got to pick the correct tailed test. And this is left-tailed. 0.05. It looks like I still have this problem in there, just with a different level of significance. Yeah, those are the same numbers. So you see, okay, I like the way I did it in the spreadsheet here. The calculators, like I said, I went 111,222. And there's that p-value, 0.0049. Critical value if we need it, test statistic if we needed it, and there we go. And here it is right here. Wait, what? Uh-oh. Is it? Oh, there's a. Okay, I'll be reposting these notes. All right, well, I need to cut this out. I have a wrong. It didn't affect the p-value, but I still want it to be accurate, obviously. So let me come over here and okay, so just have the wrong p-value in there. All right. Okay, there we go. So if we were using critical values and rejection regions, so I did inverse norm, 0.05, 0, and 1. And you see it's negative 1.645. So you would reject the hoe if Z is less than negative 1.645. And therefore we reject. Now I showed you those. I think I've showed you you can do them, the norm, S, inverse, whatever. But yeah, frankly, I think I would just, if I was using spreadsheet, in other words, once you put in the 0.05, like right there, so you put in the 0.05, there's your critical value right there. There's the command right there. You see norm, but yeah, just you might as well just put the level right there. There it is. Quick and easy. Wonderful. Alrighty. Survey indicates the mean per capita credit charge for residents of New Hampshire and New York is $3,900 and $3,500 per year, respectively. Now, since New Hampshire is first in the problem, I'm going to treat them as Group 1, and then New York will be Group 2. The survey included a randomly selected sample size of 50 from each state, and sample standard deviations. Now it says sample standard deviations. I wrote them down as population standard deviations. That's okay, because this section is all going to be, like I said, because the sample sizes are more than 30. So even though I know that makes a difference in some of the other stuff we've been doing here, it's okay that I wrote it that way. Technically, it's probably S1 and S2, but it's okay. Nothing's going to affect this. So even though I wrote them as population symbols, you can even change that to population if you want to. It's quite all right. It won't matter because the ends are going to be large enough in this section to where either standard deviation is fine. All right, so I wrote all the data right here. Let's do the calculator. Stat, test, 2 sample z-test. Standard deviation 1, 900. Standard deviation 2 is 500. First mean is 3,900. First n is 50. 3,500. N2 is 50. And this is, I guess I didn't read the rest of the problem out there, did I? Excuse me. At 0.01 alpha, is there enough evidence to conclude that there's a difference in the mean credit card charges? So difference, yeah, so if it just says difference, that means not equal. You know, don't read too much into this. Don't think of it as, well, does difference mean more? It means less? No, they're talking difference means either way, you know, more or less. So difference means not equal, and that's the claim. So the claim is the ha. So if we're going to support that claim, we're going to need to reject that ho. And let's see what we have. And the p-value you can see is 0.0060. That is less than 0.01. See, it's got that extra 0 in front of it. Be careful. I showed you that, I think, a trick in a previous section where, you know, if you move the decimals over if you needed to, like this case, if you moved them 4 to the right, you'd have, actually you could move them just 3, but 3 would give you 6, and move 3 over here, you'll have 10. So basically it's multiplying both of them by 1,000, and then you would easily see that 6 is less than 10. So, all right, we reject the whole, and we support the claim that there is a difference in the two means. I'm not going to retype these for this one. Let's kind of look. So everything is, put everything in there. Sample mean 1, standard deviation 1, sample size 1, sample mean 2, population standard deviation 2, sample size 2. There's your p-value. And the critical value method. So you can see the spreadsheet. Once you have that 0.01 in there and you see we're using the two-tailed hypothesis test, there's your two critical values. Using the calculator, you would have to go inverse norm 0.01 divided by 2, which gives you the left one, but we know that the left and the right one for any two-tailed test, they're the same numbers, one's negative, one's positive. All right. So, our decision rule in this method will be reject the ho if z is less than negative 2.575 or greater than 2.575. So we'll look at the Excel, and I'll go, there's already test statistics 2.747. It looks like I just rounded to 275. Should be the same thing in the calculator. There it is. There's your test statistic up there, 2.747. That's going to be greater than 2.575, so it falls in the shaded rejection region. There's two regions, but it falls in the right one, either one of them, it'll be reject. So there we go. So we reject the whole and we support the claim. There's a difference in the two means. Beautiful. We'll do one more of these, I believe, and then, yep, and we'll go to the homework. Okay, guidance counselor claims that high school students in a college prep program have higher ACT scores than those in a general program. So we'll treat the college prep will be group 1, as I've labeled down here because it was the first thing we saw. And the general is group 2. So I won't read all the numbers, so I copied the numbers here. 22.2 is the mean for the college prep. Standard deviation is 4.8. And 49 is the sample size for college prep. And then for the general program, 44 is your N2, 20 is your ACT average score, and then 5.4 is the standard deviation. So the counselors claiming that the college prep program have higher ACT scores. So in this problem, unlike the last one where it told you what it was trying to, the hypothesis with the last statement, here it's the first statement right off the bat. So they're telling you college prep have higher, so they're claiming then that group 1 is higher than group 2, more than group 2. So we have mu1 greater than mu2. That's our claim. It's going to be a right tail test. So less than or equal to is going to be your HO. I wrote the alpha down there, so we can put this on the calculator. All right. And two sample z-test. The first standard deviation is 4.8. Second one's 5.4. First sample mean is 22.2. First sample size is 49. Second mean is 20. 20.0, or just 20 is good enough. N2, 44. And this is right-tailed, so we got to go pick that. Calculate. And here's our output right here. So we can reach an answer for this. Since 0.0192 is less than 0.10, we reject the HO, and we do support the claim that the mean ACT scores for students in the college prep program is greater than the scores in the general program. Wonderful. Let's look at the Excel. Pretty straightforward here, I think. Just make sure you pick the right-tailed test. So 0.1 was the level of significance. And so the numbers for the first group were 22.2, 4.8, 49, 20, 5.4, 44. There's the p-value, there's the critical value. So now we're trying this with critical values. Now, just like before, when you want the right tail value in these inverse programs, whether it's norm or t, we're not using inverse t in this section, you have to put 1 minus your alpha. So there's 1.28, whereas all you got to do here is just put in 0.1 and then 1.28 right there. So your test statistic, either from here or up there, same thing, 2.067, whatever. Here it is in Excel, 2.067. Well, just drew a little picture here to show you. So 2.07 is greater than 1.28 for a right tail test, because there's your decision rule. You reject the hoe if z is greater than 1.28, so 2.07 would be greater than 1.28. Therefore, you reject the hoe. And now it's time for homework. All right, let's take a look at a couple of problems here in the homework. We're comparing dry braking distances of 2 makes of automobiles. Safety engineer conducts braking tests for 35 models of make A and 35 models of make B. So make A will be group 1, make B will be group 2. Okay, I won't read all the data there, but at alpha equals 0.10, can the engineer support the claim that the mean braking distances are different for the 2 makes of automobiles? Okay, are they different? Different means not equals. Okay, so this is easy question to answer here. And the ho and the ha are going to be equal, not equal. Critical values. So do this one in the calculator. If you go second distribution, inverse norm, 0.10 is two-tailed, 0.10 divided by 2, and then the positive of that number, so it wants 2 decimal places. So I'm going to go negative 1.64, comma, positive 1.64. Let's see how we're doing. Tremendous. What are rejection regions? Well, this is weird. They put these commas in there. It should have the word or between them, but that's okay. That's, on a test it would say or, but that doesn't hurt anything. It's obviously that's the right answer. I've never seen it written that way before. The test statistic. All right, so now let me split this apart. So let's see, stat, test, 2 samples z-test. Let's see, the first standard deviation, make A, is 4.7. Second standard deviation, 4.5. The mean braking distance for make A is 41. Okay, so both sample sizes are 35. So N1 will be 35 and N2 will be 35. But then the braking distance for group 2 is 42 feet. Put in 35. And this is equal, not equal. Right. Now, this one's asking, yeah, it's doing it by critical value method, but I'm going to mention the p-value. Test statistic right there at top, 2 decimal places. I don't think I have to put the 0 in front, but I will. Negative 0.91. All right. Now, so the rejection regions are outside of negative 1.64, positive 1.64. Negative 0.91 will actually fall between those two numbers. So we're not going to reject. But here's, even though it didn't ask the p-value in this problem, we can use the p-value. So you see the p-value is 0.363 whatever. That's way bigger than 0.10. So p-value greater than alpha is fail to reject. So that's if you're not sure, you can use that to and then fail to reject. The test statistic does not fall in the rejection region. So you really, like some of the problems in my notes where I drew that graph and whatever, you don't have to actually do that if you just want to use, you can just use the p-value even though it doesn't ask for it. All right. At the 10% level significance, there is, let's see how they're going to want to word this. The claim is different. So there is insufficient evidence to support the claim because we didn't reject the hoe. It should be different from. This should be okay. Let's see how we did. Excellent. Let's take a look at this one. All right. Let's see, what are they claiming here? So region A will be first, so that'll be group 1, region B will be group 2. Let's see, researcher claims the wind speed in region A is less than region B. So right here, and so symbolically, we're going to have a left tail test. Oh, dang. Let me stop for a second here. I did not put this in Excel, the last one, but I'll do it right now. I think I'll just get the numbers from I can't go back to the problem, I'll have to get them from the calculator. Because if I go back to the problem, it will change the numbers. So I'll just kind of put them in as I see them. That's a 4.7, and that one's a 4.5. They're both 35s. And level significance was 0.10. And the sample means are 41 and 42. All right, that looks good because there's that p-value, same p-value, negative 0.363. There's the test statistic, negative 0.909, and then there are your critical values. So there it is in Excel. Now I can go back to where we were. So let's see what we got here. Less than means the ho will be greater than or equal to, and the ha will be less than. critical value, the calculator. For a left tail test, you just do inverse norm of the value itself, which is 0.05. No divided by 2. If it was a right tail test, we'd do 1 minus 0.05. Oh, okay, yeah, 0.05 one tail is the same number as 0.10 two tailed. So it's negative 1.64. And we've got, this will be less than negative 1.64. Find the standardized test statistic. So here we go with the two-stat z-test. And our first standard deviation is 2.8. .2. And first sample mean is 14.1. And it says 90 days in each region, so both ends are going to be 90. X2 bar is 15.1. And that end will be 90. And this will be left-tailed, so right there in the middle. And we have the test statistic of negative 2.23. All right, got it? So let me put this in Excel here before I forget. Left-tailed, 0.05. I do remember both ends here are 90. And let's see, something 14.1 and 50. Region A, mean speed 14.1 and standard deviation 2.8. I believe that's 15.1. I want to say 3.2. That's probably not right. Ah, it is 3.2. 15.1 and 3.2. And I just see what I did wrong. You probably saw it the whole time I was doing it, but easy fix. I used right-tailed instead of left-tailed. Oops. But watch this. You know, we can do right this and come up here to this one, and it's fixed. There we go. So yeah, okay. Just I did not. You know, I keep preaching to pay attention to which one you pick, and I just messed up. So all right, there you go. It can happen to any of us. But actually what clued me in immediately, see, it doesn't matter on the test statistic, but I saw I saw the p-values. I knew that p-value was not close to being right. So there's your test statistic. There's your critical value. It's not asking for the p-value, but you can look at it right now and see that the p-value of 0.01 whatever is less than 0.05. So we've got reject for sure. Reject. There is enough evidence to support, because their claim is the researchers claim that region A is less than the speed in region B. Hooray for us! So let's take a look at one more. Okay, here they just have everything set up. I wanted to do this one because it's asking the p-value. So you can see it's a two-tailed, equal, not equal. It's got our standard deviations, everything laid out easily for us, so this should be quick and easy. Stat. All right, there we go. Test, 2 samples E. 3.4 is the first one. 1.4. And the first sample mean is 17. First N is 30. $15. And second N is 28. Nope. Equal, not equal. Hit that one. Calculate. Alright, so this will be equal, not equal here. It only wants the alternative, excuse me. Okay, there we go. I guess because they already gave us the... So they're telling you the claim is equal. So there's no story involved in this problem. Test statistic, 2 decimal places, how about 2.96? P-value wants 3 decimal places. 0.003 sounds good. And the decision p-value 0.003 is going to be less than the alpha of 0.01 because of the extra 0 in front. So we're going to reject. So we're rejecting the hoe, and the hoe is the claim. So that means there's 2 different reject answers, but we want C because we're going to reject the hoe. There is enough evidence to reject the claim because the claim was the hoe. Excellent. Okay, that was, let me just put this in Excel real quick. Move this over some. Can't tell which one I'm grabbing there. Move this one in. I guess all I want to be able to do is see the numbers there on the right. Make sure. Okay, now I got enough view here. Alrighty, two-tailed. I'll make sure I get that right this time. 0.01. Sample mean 17, N130. Sample size 1 is, let's see, what did I do wrong? Oh, sample mean 17. Oh, standard deviation, okay. Standard deviation, I messed up, 3.4. Now we have 30. And this sample means 15. 1.4. And this sample size is 28. And there's the p-value, 0.003. Oh, we didn't ask for the critical. There's your test statistic, 2.96 that we got. There's a 003. And I think we finished the question. Yeah, I believe so. All right, well, that concludes this video on testing between independent means, population standard deviation known, or more accurately, large samples take care of that also.